So welcome to my presentation today. We're gonna discuss about the 14th and 15th lecture today on synoptic meteorology, and hopefully we can cover cover this chapter today. So before we start today's topic, I wanted to describe one definition because it was associated with fronts, as we discussed about air masses and fronts in the last class. Uh, I should discuss that things first, and then I'm gonna describe about other topics such as cyclones, anticyclones, hurricanes, and then thunderstorms and tornadoes. Those are some weather phenomena, and we're going to describe about that. To describe that, I wanted to show you some videos from YouTube, so that you can be it could be helpful for more deep understanding. So dry lines. Dry lines is a concept. It's a phenomena that is associated with fronts, uh, and this is a different differentiation between two different air masses. When come together, their temperature becomes same, but their humidity is different. Then the dry lines has been generated. So this is the boundary actually, and it is very important because fronts are very much associated with this type of phenomena. When one air masses come to with in connection with other type of air masses, then basically they have different temperatures, and they have different humidities. But when they join together, they remain together for long time, then it could be happen that the temperature remain in a constant positions all along the clouds, all along the air masses, but their humidity has been differentiated between one another, because sometimes the high amount of the heat that can create the air masses become light. And on the other hand, when some of the air masses they can reach in a certain level of the atmosphere, they become come together again, and they form the liquid and solid form together. So those vapor pressure which created in the top of the atmosphere, they become heavy at that time. And the lower area which air masses possess in the lower height, they become more lighter than the upper one. So differences between that two created the gradients of the humidity. That means the differences of the humidity, and this could be easily be found frequently found throughout the Great Plains, and it is a very important factor which can contribute to develop a storm. So this is associated with the fronts. Now we are going to describe about some phenomena. First of all, cyclones and anticyclones, even hurricanes also, but cyclones and hurricanes that are actually the same phenomena, but that is named in different areas differently. For example, we say cyclones in Indian Ocean, by the side of the Indian Ocean and the Bay of Bengal. The same pattern, the same weather phenomena. If it is happened by the side of the China and Japan, we say it is typhoon. And the same things in Australia, it has been said as willy willy. On the other hand, if it is by the side of the North America, we say this is hurricane. And that is the differences between cyclone and anticyclones. From the name, we can understand anticyclones is opposite of cyclones. So what does a cyclone means? Cyclones is a phenomena which is associated with differences of the pressure from between the outer side of the storm, outer side of the eye, and inside the eye. So inside the eye, there is a low pressure center that has been created inside the cyclone, and the outside of the cyclone, that is high pressure center. So when evaporation takes place on the top of the water surface, they become lighter. They wanted to go to the top, And with this lighter effect, as it is a low pressure system, they, when they move to the top, the center become vacuum, they become vacant, and these vacant places that has been replaced by the other cold air which is coming from different directions in the lower level. So this is the main starting of the cyclones, and then that has been moved to the upward. How they can be developed, we're going to describe now. And in case of the cyclones, in case of the cyclones, the air masses that are heterogeneous in nature, that means their characteristics is different. Their moisture, their temperature is different than one another's, and they are coming from different geographical regions. uh, it is also important that these cyclones is a greater factor in temperate latitudes, that they become also create winter precipitation in that area. On the other hand, anticyclones is in opposite direction. That means in the center of the anticyclones, the pressure is high enough. So we say this is a high pressure center. uh, Maybe we need to understand what is low pressure and what is high pressure center. Generally, we do think that we do know that the surface of a water bodies, that means the sea level, the air pressure should be 1013 millibar, or you can say 1010 millibar. So greater than that, it is high pressure, and lower than that, it is low pressure center. Generally, this is the idea. So when the pressure system has been seen that there is a differences between outside the center and the inside the center, so this can create the differences, and this can create an unstable condition that creates a cyclone. How the cyclone has been developed. So there are a couple of conditions of cyclone formations. We're going to describe that. But before that, you can also see the stages of the cyclones, how it has been formed. So first of all, we need a place where the sun give us sun heats up the area, so that for a long time and the evaporation takes place. And for a long time, when evaporation takes place, that means that area is continuously vacant due to these lighter air masses. And these air, or what we can say the vapor with air, they become move upwards, and continuously they are moving upwards. Normally in every day, when the ocean, they are actually acting this type of phenomena. But if the ocean surface is characterized for a long time with this great amount of the heat, which is more than 26 degrees centigrade, somewhere it is written as 27 degrees centigrade. So that causes the huge amount of the evaporation from the ocean, and that energy has been stored in the top of the atmosphere, top of the troposphere. This is the first stage. And now the cold air, which is coming from different directions, that has been emptied, that has covered the vacant places, and that vacant places again, they become heated up, and they also go to the top of the troposphere. In this way, this arises in a continuous process, and this process is the starting of a cyclone formation. When they move to the up to the top of the troposphere, that become very cool again, because height also give us the low level of the temperatures, and that becomes again cold, and they wanted to come to the downward again because of the heavier situation. So that is a that creates some clouds on the top of the troposphere, and this cloud has been increased with a great circumferences. So now in the second stage, a vortex has been created. A vortex has been created due to two different ways, two different forces. One is a Coriolis force. I will gonna explain now what does it mean. Coriolis force. Another is the spinning movement. So the wind is moving in one direction, and the opposite direction the Coriolis force is acting. That creates this circle, or not circle, I say a spiral bending of the wind, and that is we termed as vortex. Now, may I ask you, do you know what do you mean by Coriolis force means? Did your other teacher, Dr. Shamol, explain what do you mean by Coriolis force? Do you have any idea about Coriolis force? Hello?
No, sir.
No. Okay. Let's discuss about the Coriolis force. Coriolis force is an important phenomena. Oh, I'm going to describe about that. Let's see this one, and then we're gonna see some. We're gonna see some. Sorry. Mm. Can you see a new slide now?
Yes, sir.
Yes,
Okay.
sir.
Okay, so Coriolis force is a very natural phenomena of the Earth because Earth is always moving to the west to the east. Okay, and this movement causes the things to be changed. Um, think about three positions in a perpendicular nature, very straight: Toronto, Miami, and Quito in the left figure. The places are very straightforward. Okay, now if you think about a aeroplane is moving from Quito to Miami and another plane Toronto to Miami, in the very perpendicular nature, maybe on the 90-degree angle, and they are not changing their positions, they really goes to the 90-degree angle, then what do you think what will happen? Actually, in the right figure, you will see the places of the blue color, the Toronto, from Toronto, the plane, if it go very straight, that time that will be come to the left side. And from Quito to Miami, the right side, the place has been going to the right side. Why? Why? The plane, not the place, sorry. The place is always in the same places, but the Miami in the middle, maybe the places will be remain in the same way, but the direction of the plane will be deflected, and the plane will landed from Toronto to Miami. The plane would landed in slightly right position, and the uh, plane from Quito to Miami, that will land at little bit left positions from the Miami. So this will be the consequence due to the earth rotation, because maybe it needs couple of hours or maybe 1 hour from here to here and here to there. So that's why within this time the earth will has been moved and the places has been changed. That means the plane will gonna not land in the right place if it moves very perpendicular, very right directions. Is it understandable? Can you understand that?
Yes, sir.
Okay, so this is happened due to Coriolis
Sir,
force.
what will happen if they don't change their direction, sir?
Then they will gonna come in the left direction. If from Toronto to Miami, they will come to this position, and from Quito to here, they will come in that position. They're not gonna land on
Maybe,
Miami.
sir. Okay,
Yes.
sir.
Okay. So you can also ask me, so how the plane can move. Basically, the plane is now very automated in a formation. So they have a longitude and they have a latitude in their positions. So for example, from Chittagong to Dhaka, when we wanted to go by aeroplane, the pilot, they have been set up a position of latitude and longitudes, and the latitudes and longitudes of Dhaka, that has been changed during course of time. So maybe it needs 25 minutes from here to Dhaka, and during this time, how much area, sorry, how much distance the Dhaka has been moved to the right direction, they can calculate. And with this calculation, they have been set up in their direction, and then this direction will take them to Dhaka. Can you understand? So before starting, what is the actual position of the Dhaka now? If you go to the Dhaka with that direction, then you cannot go to Dhaka, because within these 25 minutes, Dhaka also shift couple of kilometers away from its original places. Is it okay for you? Can you everyone understand what I wanted to mean?
Yes, sir.
Yes,
Okay.
sir.
So if you understand
Sir,
that,
is there any exact calculation, sir? How much distance they cover?
in one, normally what do you calculate? That's in every 4 minutes, 1 degree has been changed.
Yes, sir.
Yeah, yeah. In 1 hour, yes, like that.
Sir,
Yes,
1 hour, sir. Four,
one
4 degree
hour,
in
1 hour in
Yes,
60
sir.
minutes. In 60 minutes, yes.
Yes, sir.
So this is the exact changing, because the rotation is very constant of the Earth's surface. Now, now, if you understand that, let's see a video to make us more clear about the Coriolis effect, because in the northern hemisphere we do have different uh, in the northern hemisphere we do have different understanding than the righter direction. Let's Coriolis effect. Maybe this one. Let's see. uh, Coriolis force. Let's see this
In this
one.
view of
Can you
Earth
see
from
the
space,
video?
it is clear that the Earth is rotating. However,
No,
as you
sir.
are on the surface of the Earth,
You cannot see the video?
No, sir.
No, sir.
No,
indicating
sir.
Okay, let's
is in the
see. Let's see. Hmm. Is it okay now?
Yes, sir.
Okay,
observation of the sun
let's
during the
see.
day and the stars during the night. Every day the sun rises in the east and sets in the west, but we are completely unaware that we are traveling to the east at hundreds of miles per hour. So just how fast are we moving? Well, at the equator, the rotational velocity of the Earth is an incredibly fast 1,018 miles an hour. If you were to travel from the equator to about 30 degrees north latitude, the rotational velocity would have slowed considerably to about 882 miles an hour. Well, why? Well, as you walk north or south from the equator, you are actually getting closer and closer to the Earth's axis of rotation. Because the surface of the Earth is solid, the rotational velocity will decrease as you walk north or south from the equator, because you're actually getting closer and closer to the Earth's axis of rotation. To understand this better, let's imagine that we take the Earth, a sphere, and flatten it out into a rotating disk, like a merry-go-round. If you were to stand on the edge of the merry-go-round, the rotational velocity would be large, and you would feel like you're going to fly off. However, if you stand in the middle, the rotational velocity would be much less, and you would feel like you're barely spinning at all. Now, what if we were to have two people sit on opposite sides of the merry-go-round and try to throw a ball to one another? You can see that as the ball leaves the hands of the person throwing it, it becomes independent of the rotation of the merry-go-round, and therefore follows a straight path. But because the person trying to catch the ball is still rotating with the merry-go-round, they are quickly moved out of the ball's intended path. Because the merry-go-round is spinning counterclockwise, this deflection is to the right. If it were spinning clockwise, the deflection would be to the left. Now, to an observer above the merry-go-round, the path of the ball appears straight. However, to people on the merry-go-round, the path of the ball curves to the right of the intended motion. This experiment demonstrates how the rotation of the merry-go-round appears to cause a deflection in the path of the ball. This also demonstrates how air movement on the Earth's surface can be deflected by the Earth's rotation, a phenomenon called the Coriolis effect. How do we relate the effects of the Coriolis force to air motion in our atmosphere? To answer this question, let's first investigate what
So they have many other descriptions also, but basically the idea is same.
would
So
happen to a parcel of
we
air
can
that was initially
also go for a little bit other one, so make it more clear about this one maybe. Let's see this one.
Good. So the Coriolis effect is an apparent curve of the path of different objects as they move within something that's rotating. For us, we're going to focus on the Coriolis effect in wind. Now, we all know that air always moves from higher pressure to lower pressure. So in this diagram here, we've got a high pressure system and a low pressure system. We would assume that the air would want to go from the high pressure system towards the low pressure system, and it does. But since the Earth is rotating, the actual motion causes that wind to curve to the right, at least in the northern hemisphere. In the southern hemisphere, it'll curve to the left. So the wind will do that, The wind will curve to the right as it's moving along instead of just going straight from high to low. The reason this happens is because the Earth is rotating. It's known as the Coriolis effect. So if we look at, here's a nice definition for your notes: the wind appears to curve due to the Earth's rotation. That's why this curve happens. It's all because the Earth is spinning, all because the Earth rotates. If the Earth was staying still, if the Earth wasn't spinning, then the wind would move straight, the air would move straight from high pressure to low pressure. We wouldn't have this apparent curve that we see. If we take a look at a globe, here's the Earth. If we put a high pressure here, and let's put a low pressure here. So there's our high pressure and low pressure. We would assume that the air would move from high to low, and it does. The air is going to try and move from high to low, but it's going to curve to the right. Now you might look at that and say, oh wait, he just made a mistake. He said curves to the right, but that arrow is going to the left. Yes, but you've got to be the wind. So what we're going to do is we're going to rotate this, and we put it in an orientation so we could see that the air is moving from the high to the low, that it does curve to the right. You've got to put yourself in a position so that you're facing the same direction that the wind is moving. The air is going to move from the high to the low. It's going to curve to the right. In the southern hemisphere, that curve is to the left. So if there's a high pressure system here, a low pressure system over here, in the southern hemisphere, the air wants to move from high to low, but in the southern hemisphere, that curve is to the left. So we see that in the northern hemisphere, the curve is to the right. In the southern hemisphere, the curve is always to the left. And it's important that you face the same direction that the wind is facing. So we see a curve to the right in the northern hemisphere, and the southern hemisphere, that curve is always going to be to the left. And that's going to affect the way storms circulate, the way they rotate.
So this is about the how they move, the Coriolis effect. So now this is also important for our cases also in our storm development. We were discussing about the storm development. Sorry, this one. Okay. So can you see the slide now? Hello. Hello, can you see my slide now? Hello, can you see my slide now?
Yes, sir.
Okay, sorry for the internet connection. So if you can understand about the Coriolis force, now you can understand this one. So Coriolis force, which can give us the idea that air moves to the left direction, right direction in the northern hemisphere. On the other hand, the winds that wanted to move in their own way, in the opposite direction. So that two effects, when joined together, they have the opposite direction and they create some spiral band. This spiral band we termed as a vortex. They created a vortex. And the next round in these vortex, when created in the top of the troposphere, these circumferences has been developed. And this is so big, sometimes, most of the times it is more than 300 kilometers. But in case of Indian Ocean and Bay of Bengal and by the side of the Arabian Sea, it could be sometimes more than 1000 kilometers. So now you can understand how big it is. More than 1000 kilometers means it can occupy whole of Bangladesh, like that. So this is the way how it has been formed. We're going to see some videos about the tropical storm formations. But before that, just a quick understanding that this is the eye of a cyclone, and this eye is characterized with low pressure system. In the northern hemisphere, it has been moving like counterclockwise because of that forces that I described about the Coriolis force and about the spinning of the wind. And the outer side of this one, maybe here and other areas, the differences between this eye and here is huge. It has been said that it is created in the Hurricane Elena in 1985, that they said the pressure, central pressure, that means in the eye, the pressure is 955 millibar. Okay, so if it is in 95 millibar and outside is 1010 millibar, the differences is huge, nearly 65 millibar. And these differences causes that the wind or the air that is coming from high pressure to the low pressure system. So wind is coming from this way, from different directions in the downward, they move to the upward with its high amount of the heat, and then its circumferences getting bigger and bigger one. And the question is how long it will it will gonna take places with this type of phenomena. So it will gonna develop until the sources of this humidity or until the vapor pressure that should be disconnected. So when it is disconnected, then that will be these storms is this storm dissipates. So how that can be happen? That can be happen when these water surface, the cyclones on the water surface that come to the land surface, the sources of uh, the sources of the vapor or humidity has been cut off, and then it dissipates. So this is the way how a cyclone has been formed and then dissipates. So there are a couple of conditions which we have discussed already now, that has been described by Gray 1975 related to tropical cyclone formations. They say six major environmental factors that is needed for a cyclone formations. One is they need a large values of the low level cyclonic activity. So low values of the low level cyclonic relative vorticity. Vorticity means this vortex creation, and then they also need a location with less than few meters, few degrees from the equator, maybe 5 degree to 20 degree. That is very suitable for cyclone formations. Cyclone cannot be formed in the Arctic region or greater pole division, polar areas, or maybe very 0 degree to 5 degree. It might not be possible because of the weak forces of these vortex creation. Then there should be very weak vertical wind shear and large values of the humidity. That means they need this humidity to grow up a huge amount of the clouds. And they are also conditional instability throughout a deep tropospheric layer, and their sea surface temperature should be above 26 degrees centigrade. Somewhere it is written as 27 degrees, somewhere it is written 26.5 degrees centigrade. This is a satellite image of the cyclone Cedar, which has been generated in the Bay of Bengal, and this moves towards the coast by the side of the Bangladesh and the Myanmar in 2007. The inside eye, here is the eye. This eye, here the pressure was at that time 937 millibar, and the outside is 1010. So the difference is created the wind come to from different direction to that way, and then heated up and for risen up, and they become a huge created a huge clouds of circumferences. And these spiral bending that has been created due to different two different forces. One is Coriolis force in one direction, and another direction that is created by other spiral bending of the winds. Both of them created the spiral bending. So now, before we starting to a video, just to make a quick understanding that cyclones can be named in different areas with different names, different locations, and cyclones has a speed of more than Sometimes it is more than 200 miles per hour. But when it is more than 73, we can say per hour, we can say hurricane. But super cyclone is more than 200 mile per hour. And they have been a very, they are very and they are very great source of electricity, or you can say energy, which is more than 300 to 400 billion kilowatts per hour of energy per day they can produce. And they also have a huge amount of the shower, because of high amount of the humidity they can evaporate it from the ocean surface. Now, before we go for a video, just to make a quick understanding that this Hurricane Katrina also has a greater speed of 175 mile per hour, which has a low pressure system in here is 907. So 907 and outer is 1010. That means a huge difference between one another. The greater the difference, the speed will be more, because with that speed the wind wanted to occupy the vacant area, or vacant places, and that vacant places again risen up and again created the vacant places. So this is all about this cyclone. Now we're gonna go for a quick video, two videos actually. We need to understand that, and then if you have any question, I'm gonna share it. Formation of a
Because
cyclone.
of this, because these winds are curving to the right and curving to the left, it sets up certain wind belts or patterns of wind on the earth. So if I take a look at the earth here,
Yeah. Maybe let's see this one, formation of a cyclone.
There are three basic stages in the life of a tropical cyclone: its origin or source, the mature stage, and the dissipation stage where it dies out. These occur in a continuous process, not as separate and distinct stages. Each stage may occur more than once during the life cycle as the strength of the cyclone rises and falls. It may reach land, weaken, then go back out to sea where it strengthens once more. The formation of a cyclone depends upon the following conditions coinciding: a large, still and warm ocean area with a surface temperature that exceeds 26.5 degrees Celsius over an extended period. This allows a body of warm air to develop above the ocean's surface. Low altitude winds are also needed to form a tropical cyclone. As air warms over the ocean, it expands, becomes lighter, and rises. Other local winds blow in to replace the air that has risen. Then this air is also warmed and rises. The rising air contains huge amounts of moisture evaporated from the ocean's surface. As it rises, it cools, condensing to form huge clouds about 10 kilometers up in the troposphere. More warm air rushes in and rises, drawn by the draft above. The rising drafts of air carry moisture high into the atmosphere, so that these clouds eventually become very thick and heavy. Condensation then releases the latent heat energy stored in the water vapor, providing the cyclone with more power. This creates a self-sustaining heat cycle. Drawn further upwards by the new release of energy, the clouds can grow to 12 to 15 kilometers high. The force created by the Earth's rotation on a tilted axis, the Coriolis effect, causes rising currents of air to spiral around the center of the tropical cyclone. It is at this stage that the cyclone matures and the eye of the storm is created. As the air rises and cools, some of this dense air descends to form the clear, still eye as the cyclone rages around it. The eye wall, where the wind is strongest, behaves like a whirling cylinder. Cyclones rotate clockwise in the southern hemisphere, anti-clockwise in the northern. The lowest air pressure in a tropical cyclone is always found at the center and is typically 950 millibars or less. The average air pressure at the Earth's surface is about 1010 millibars. Tropical cyclones have significantly lower air pressure than the air that surrounds them. The bigger the pressure difference, the stronger the wind force. One of the lowest air pressures ever recorded was 877 millibars for Typhoon Ida, which hit the Philippines in 1958, where winds reached 300 kilometers an hour. Once formed, the cyclone's movement or track follows a pathway away from its source, driven by global wind circulation. The water, moisture, the cyclone enlarge.
Can you understand what this shows in here? Is it okay for you?
Yes, sir.
Okay, so I'm gonna explain a little bit more, but before that, maybe we can see. Let's see another one. Maybe this one. Yes, tropical cyclone. Maybe from here. So with this video, we're gonna also see from these videos that how the wind and the Coriolis effect happen in the cyclones and what are the places it can be happen. Let's see this one, and then
in this video, we're going to learn about tropical cyclones. The first thing you need to understand is that tropical cyclones originate over oceans in tropical areas and coastal regions. If you all know, this is the tropical region. It is the region of the Earth near to the equator and between the Tropic of Cancer in the northern hemisphere and the Tropic of Capricorn in the southern hemisphere. Tropical cyclones are known by different names depending on the region. In the Indian Ocean, they are known by simply cyclones. If you go to the Western Pacific side or near the South China Sea, it is called as typhoons. Likewise, near Western Australia, it is known by willy willies. All these are different names refer to the same type of storm. You must be knowing this, that tropical region receives the most solar radiation per area. And the reason behind that is due to the incoming solar radiation that are direct and vertical at the tropical region. And as you move towards the polar region, the angle of the sun rays are not vertical, they are slanting rays. Vertical rays of sunlight are more effective in producing light and heat than slanting rays. And that's why the tropical region is warm. Now that you have understood the main things about the tropical region, let's understand about wind movement. Wind movement is determined by low pressure and high pressure systems. It is the differences in atmospheric pressure that creates pressure gradient and makes the wind move. And wind always blow from the areas of high pressure to low pressure areas. Now the next question is, what causes low pressure and high pressure? Low pressure occurs when air is warm, either from being over a warm land or ocean surface. That means low pressure occurs at a place which is warm. And how does a place become warm? Because of the incoming heat from the sun. That is why tropical region is a perfect place where low pressure occurs. Similarly, high pressure occurs when air is cool, either from being over a cool land or ocean surface. That is why in the polar region, that is your north and south pole, it is a high pressure zone. And always remember, winds blow from the areas of high pressure to low pressure areas. While all of this happens, there's another important phenomena which comes into the picture. It's called Coriolis force. Due to the rotation of the Earth rotates towards the east, and that's why the sun, moon, planets, and stars all rise in the east and go towards the west. Anyways, due to the rotation of the Earth, there is a force that is generated, and it acts perpendicular to the direction of motion and to the axis of rotation. In simple terms, when the Earth is spinning in its axis from west to east, and we also know that Earth is a sphere and it is much wider in the middle. As a result, the speed of the surface of the Earth at the equator is much faster than the speed at the poles. So if anything has to come straight from the poles towards the equator, it gets deflected to the right in the northern hemisphere. And
so this is you can understand very well that you see the equator 0 degree is wider, no, and it is very a smaller area. So that's why the speed is somewhere is great and somewhere is very minimum. And from here to here, if anything perpendicular wanted to come, then they will be deflected because the speed difference between the equator and difference between the equator and the pole. This is the main causes of the Coriolis effect, and it should be as it west to east. So if your direction is from north pole to equator, then your thing should be deflected to the right. In here you can say that no, it is left, but actually it is right, because when your face is from north to south, that means from here to the poleward, then it will be right. On the other hand, in the southern hemisphere, from here to here it would be left, because we need not to change our positions in that time. So from here to here it is left, and here to here it is right. This is Coriolis force. Now see how this Coriolis force have some effect on the spiral vortex creation in the cyclone.
and to the left in the southern hemisphere. And this force that we are talking about is called Coriolis force. It causes fluids like water and air to curve as they travel across or above the Earth's surface. Due to Coriolis force, the air in the northern hemisphere gets deflected to the right side. Now you might think, no, that is going towards the left side. But then I said the air is going to curve to the right side in the northern hemisphere. To clear your confusion, you have to actually see it from the direction in which the wind is moving. So what I'm going to do is I'm going to rotate this picture and now put yourself in the path of the wind. Now you will be able to see that the air in the northern hemisphere curves to the right while moving from high pressure to the low pressure area. Similarly, in the southern hemisphere, the air is deflected to the left side while moving from high pressure to low pressure area. In this case, we don't have to rotate the picture. Now that you have understood why the air moves to the left and right due to Coriolis force, just remember this point, that it is because of this reason there are certain pressure belts all over the Earth's surface. You must be familiar with this picture, which shows global wind circulation pattern. You can see that at different latitudes, there are different pressure belts. Their existence is simply due to the movement of air to the left and right due to Coriolis force. I hope so far you have understood the general movement of air. Now let's understand how does air turns into a storm and what causes the spinning of a cyclone. When you look at the movement of a cyclone, at the center of every cyclone or hurricane, you will find an area of low pressure, which attracts the cool air. Since we know that air moves from high pressure area to low pressure area, that means the outer area of a cyclone consists of cool air coming from high pressure area, which surrounds the central low pressure area. This region is called the eye of the storm or center of the storm. The low pressure region is a warm region where the air is warm, which expands and then rises. The cool air from high pressure zone rushes in to fill the void left by the rising warm air. This
See this one. So always the places which has been heated up by the sunlight, the rising one is warm, but the wind which is coming by the different sides, it is not very hot. It is very cool, not cool, very cool, but cool than this one. So when it comes, it is heavier. Now it become lighter. It goes up, and this area become vacant again, and again the wind are coming. This is a continuous process, and that's how the lighter air they go to the top of the sky, top of the troposphere.
air warms and becomes moist as well, allowing it to rise. Then more cool air rushes in to fill the void. The warm, moist air cools as it rises higher into the atmosphere because temperature drops with increasing altitude. That is also how clouds are formed. Now, this process continues again and again. As a result, you will see an eye-like figure at the center of the storm. Now comes the Coriolis effect. In the northern hemisphere, the cool air rushing towards the center of the storm is deflected slightly to the right. But keep in mind, the cool air keeps getting attracted towards.
Let's see this one. This is the most important thing, that how they create some vortex. So from northern hemisphere, if it is a pole, that means if it is a pole and if it is the equator, the wind is bending to the right direction. Okay. On the other hand, we know that air is always moving to the high pressure system to low pressure system. So here this is a high pressure system, and as we said that the I is low pressure system, so wind wanted to that direction. So the two opposite directions, the Coriolis effect they take in the right direction, the spinning is going to left direction. These opposite forces that create the spiral bending, which is called vortex.
the center, because that's where the warm low pressure zone is. While moving towards the center, the cool air keeps getting deflected. Now this creates a spin in a counterclockwise direction. In the southern hemisphere, the Coriolis effect moves air to the left, opposite to what happens in the northern hemisphere. As a result, the spinning of the cyclone is in a clockwise direction in the southern hemisphere. Tropical cyclones are intense, and in the beginning, we have read that it occurs over the ocean surface and coastal region because there's a continuous supply of moisture from the ocean or sea. When it reaches the land, the moisture supply is cut off.
So this is the dissipated stage. So when the moisture is no more coming from the land surface, the storm has been dissipated. Then we get the rainfall, and after the rainfall, the sky is clear again.
And the storm dissipates. When the cyclone crosses the coast, because after that the landmass starts. So the place where tropical cyclone crosses the coast is called the landfall of the cyclone, meaning the power of the cyclone naturally decreases because the supply of moisture is cut off. The average diameter of a circulating tropical cyclone can vary between 150 and 250 kilometers. However, the diameter of the storm over the Bay of Bengal, Arabian Sea, and Indian Ocean is between 600 to 1200 kilometers. And these cyclones move slowly at a speed of about 300 to 500 kilometers per day. So far, we have seen the top view of a tropical cyclone, and this is what it looks vertically. This is the eye of the storm. Around the eye is the eye wall. If you look at the height of the cyclone, the circulation of the tropical cyclone extends up to the troposphere. That is around 15,000 to 18,000 meters. When warm, moist air rises up in the atmosphere, after a certain height, it starts cooling because the temperature drops with increasing altitude. As the air cools, it becomes denser and moves towards the ground. This is called subsiding warm air. And this is what intensifies the storm by increasing the diameter of the storm. And as the diameter increases, the spiral rain bands expands and pushes the rain clouds into the outer region. Tropical cyclones occur at the time of maximum solar radiation during the summer and autumn season, that is around July to October time in the northern hemisphere, and December to March time in the southern hemisphere. With this, I hope you have now understood.
So I think it is much more clear now. So if any confusion you have, you may ask now about the cyclones, and then I'll move to another topic. Do you have any question regarding cyclones or Coriolis effect or anything? Hello, can you hear me? Do you have any question?
No, sir.
No. Okay. Okay, then we can move forward. Okay. Someone asked me, sometimes cyclone changes path. Why this happen? Changes path means when it's moved from one place to another place, their direction can be changed depending on the wind circulation pattern. So it is normally if it is the air masses, then they should follow the general circulation pattern. But depending on the energy source, depending on the temperature, and depending on the circumference, everything, they can change their path. Change their path means their direction is not suddenly changed, but they when they move, due to their different movement of inside the cyclonic event, they can change their directions. So there is two different changes. One is their total path, which is started from here to here, from long distance. For example, it is Indian Ocean, and from here a cyclone has been formed, and then they can come straight along, or they can go right or left, depending their circulation pattern, and their speed can varies. On the other hand, when they come to closer to the landform, then they are also been changed their path because of the environment which is coming by the coast, because each of the coast, they have different setups. Their temperature is different, their environment is also different. For example, by the side of Bangladesh and by the side of the India, the two different places, whether it may be a coast and geographical locations, with when the big circumferences moving in that directions, they can be deflected from the environmental consequences of India or Bangladesh. So it can be changed due to temperature, due to humidity, and many others. But most of the cases, it can be changes on depending on their circulation pattern. So it cannot be said that when a cyclones has been formed, they can be very straightforward come to one places. So with the differences of temperature, for example, here it has been created, and on the way to Bangladesh, it can change its position, because when they move couple of thousand kilometers forward, maybe the local temperature of that sea surface is quite different than where it has been originated. So it can be changed anyway. Okay, is it okay for you? Okay, next we try to, sorry, um, wanted to share the screen. This one. Okay. Okay, now we are going to describe about the thunderstorms. Thunderstorms is accompanied with some sorts of clouds, which is named as cumulonimbus clouds, as we discussed in our cloud chapter. So when warm air masses, basically coming from the maritime tropical areas, or maritime tropical air masses, that is filled up with huge amount of the water vapor, and their temperature is quite big enough, so they can move very very easily to the top of the troposphere. And as cumulonimbus cloud, we do defined as a low level cloud, but its top is not in the lower level. It can be extended up to troposphere, so means more than 11,000 meter, that means 11 kilometer. So with this movement, it can grows a huge amount of the water vapor, and when it goes to the top of the surface, then that surface again become cool again, because of the lower temperature. They created the huge amount of the clouds. These clouds then accompanied with different sets of precipitation materials. First of all, they become solid, and then they can be liquid again. And with this movement, they can give us sometimes snow, sometimes slate, hailstones, and obviously sometimes they can also give us thunder and lightning. And thunder and lightning has also different definitions. We're going to explain them too. But before we go for the lightning, we should understand about the thunderstorms, how they can be formed, and how we can see how they can give us those materials. So think about these these clouds. It is approaching or advancing a thunderstorms. So it has been created from the high amount of the water vapor that has been with a high amount of the temperature that has been evaporated, and they go to the very high altitudes, and they become cooled down, and their circumference has been increased. So when they have been increased, so there is a difference between these two places. So in the lower level, that is very become vapor, and that is relatively warm temperature. On the other hand, in the high level of the temperature, high level of the clouds, that is become cold, so cold that it become turned to ice sheets. And with the upliftment of this light air, we say it is an updraft. On the other hand, when the clouds become very heavier, they wanted to come down, that we termed as downdrafts. So difference between these updrafts and downdrafts, and difference between these temperature differences, many scientists thought that they created the differences between electrical charges. But however, scientists are not very confirmed that why the charges has been separated. So normally they thought the higher level of the charges, that means the positive charges, become in the top of the clouds, and negatively charged, which is lighter, they become in the down stages, and became that two different directions. So they become attracted to each other, and they created the lightning. So lightning can be also possible inside the clouds, between the clouds, and from clouds to the land level, that means in the ground level. Sometimes we say lightning also happening because of their the electrical charges come from clouds to the ground, but actually it is opposite, because from the clouds, when it created some branches, it said steeped ladder like shapes of electrical charges, negatively electrical charges, they come to the much more lower positions, very near to the earth surface. And then if any tall things of the ground level, if they have positively charged, that positively charged wanted to attract those electrical charges, and then when they come together, electrical forces, the positive charges move from top to the down to the top. That's created the lightning. And lightning is a deadly matters, which has been seen last couple of years in our country also. And some of in many cases, the people become died due to the heat of the lightning. And these lightning also happened throughout the world with a 100 times, with a rate of 100 times per second, through all over the world. Yeah, about 25 million lightning can be also recorded, estimated in USA each year. So now a quick understanding of the lightning. Maybe we can go for a quick video to make us clear about the lightning. Let's see. This one. Mm, Let's see this one.
Can lightning strike the same place twice? Let's figure out what makes it happen in the first place. Lightning is electricity, and electricity involves tiny particles. Some particles have a positive charge, and some have a negative charge. The two opposite charges pull towards each other like the north and south ends of magnets. Usually, electric charges are fairly balanced, but the turbulent winds of a storm cause electric charges to separate within the cloud. Most lightning.
You see how they separated from one another. This is not very straightforward, but they said due to some causes. Okay, For example, they said here,
But the turbulent winds of a storm cause
they say the turbulence of the air, but by the scientists it is not very clear that how the turbulence created these differences, because we know that the charges should be remain together, but in here they have been separated due to turbulence. But how the turbulence causes it, the scientists is still try to understand that.
electric charges to separate within the cloud. Most lightning occurs within the cloud itself, but we're concerned about the lightning between clouds and the ground. Lightning starts with negative charges moving from the clouds towards the ground. Scientists call it a stepped leader. Meanwhile, an upward leader forms as positive charges move up from the ground, usually from tall objects. When a stepped leader and an upward leader meet, it makes a path for a much larger and brighter electric current to shoot up into the cloud. This is what we see in the sky as lightning. It happens so quickly that lightning seems to travel from the cloud to the ground, when in fact the opposite is true. So, can lightning strike the same place twice? Absolutely. For example, Toronto CN Tower is struck by lightning around 75 times each year. In fact, in August 2011, the tower was shocked a record-breaking 52 times in 84 minutes. But don't worry, the tower was built to...
So this is all about the lightning. So lightning, we can say this is a phenomena which has been created with thunderstorm, and this thunderstorm is associated mainly with cumulonimbus clouds, and that should be on the basis, it has been created on the basis of the differentiation between the negative and positive charge separation. So now you can ask me any question regarding lightning or thunderstorm, and then we're gonna move the last topics, tornadoes. Do you have any question
No, sir.
regarding thunderstorms or lightning? Yes, someone maybe. Okay. Can thunderstorm occur without lightning? Yeah, when you say thunder, what do you mean by thunder? Thunder. Yes, maybe maybe sometimes you cannot see the lightning by your eyes, or maybe it can be we say lightning normally when that light come to that negatively and positively charged connects from ground to the clouds, we say that lightning. But thunder also causes thunderstorm also can be without lightning. It might be possible because that thunderstorms that thunder can be also happen inside the clouds, that maybe poses about the other characteristics, not lightning. It can also be possible. Yes. uh, if you don't have any other question, then I should move to the next topics as tornadoes. Tornadoes are the same thing as the cyclones, but in case of tornadoes, the tornadoes normally grow or normally can be originated on the land surface, whereas the cyclones mostly happened mostly grows on the mostly originated on the sea surface. And in the tornadoes also can be accompanied with some different types of clouds, or maybe it can also be possible that it can originate all along. But in that case, the tornadoes may not be very speedy one, very vigorous. In most of the cases, when it is greater than the 25 millibars, we say this is the tornadoes. The differences between inside and outside of a center. So inside, if it is the temperature sorry, the pressure is lower, and the outside it is higher pressure, the higher pressure from the higher pressure zone, it wanted to come back to the inside. In that cases, it try to make the circulation. And how the vortex originated, we're going to see that. But before that, we need to understand that there is no constant air vapor in here, no humidity in here. So that's why the circumference of a tornado is not too much. its speed is great because the differences between pressure system, but the circumference is not great because they don't have enough humidity that is also possible from the water surfaces. So that's why their circumference is very lower, but the speed is very high, sometimes more than the cyclones. In many cases, we have also experienced that tornadoes can create the damages one side of a road, but the other side remain as it is. So why it has been happened? Because of the smaller circumference of the tornadoes in many cases, but not always. It can exceeds its speed more than 300 mile per hour, which is huge. And with this one, it can last long very a small amount of the time, because with the dissipates when it hits some structures, it dissipates. Thus, circular spiral bending has been disrupted, and they can be dissipates, and it can be up to 6 kilometer on an average, and the duration could be averagely 10 minutes, but it can last long for a couple of hours also. So this is all about the tornadoes. Now we are trying to see how it can be formed and how it can be described in different other ways. Let's see a description maybe. Let's see this one.
They call me the tornado chaser. When the wind is up and conditions are right, I get in my car and follow violent storms. Crazy, you say? Perhaps, but really, I chase these sky beasts to learn about them. I want to share with you what I know. Tornadoes are rapidly rotating columns of air that form inside storms, then connect with the ground via a funnel of cloud. When that happens, they tear across the earth, posing a huge threat to life and property. Because of this, there's a great deal of research into these phenomena. But the truth is, there's still a lot we don't know about how tornadoes form. The conditions that may give rise to one tornado won't necessarily cause another. But we have learned a lot since people first started recording tornadoes, like how to recognize the signs when one is brewing in the sky. Are you coming along for the ride? Tornadoes begin with a thunderstorm, but not just any thunderstorm. These are especially powerful, towering thunderstorms called supercells. Reaching up to over 50,000 feet, they bring high force winds, giant hailstones, sometimes flooding, and great flashes of lightning too. These are the kinds of storms that breed tornadoes, but only if there are also very specific conditions in place, clues that we can measure and look out for when we're trying to forecast a storm. Rising air is the first ingredient needed for a tornado to develop. Any storm is formed when condensation occurs. The byproducts are the clouds. Condensation releases heat, and heat becomes the energy that drives huge upward drafts of air. The more condensation and the bigger the storm clouds grow.
So this is the way how you can see the rising air. That means it is heated up and they come to upwards. It is called updrafts, and downdrafts. It created the huge amount of the clouds, and they wanted to grow bigger and bigger, and they become more heavier. And with this wind movement, in this direction they come to in that direction, and this direction come that way. So with this movement, with the spinning forces, they created the vortex.
The more powerful those updrafts become. In supercells, this rising air mass is particularly strong. As the air climbs, it can change direction and start to move more quickly. Finally, at the storm's base, if there is a lot of moisture, a huge cloud base develops, giving the tornado something to feed off later, if it gets that far. When all these things are in place, a vortex can develop enclosed by the storm and forming a wide, tall tube of spinning air that then gets pulled upwards. We call this a mesocyclone. Outside, cool, dry, sinking air starts to wrap around the back of this mesocyclone, forming what's known as a rear flank downdraft. This unusual scenario creates a stark temperature difference between the air inside the mesocyclone and the air outside, building up.
So this is all about, you can see the hot air is moving to one directions, which in a circular formations. On the other hand, downdraft with the cold temperature, they wanted to come in other directions. Both the cases, they created this spiral bending. So tornadoes is another phenomena which can be associated with sometime, most of the cases, the storms and thunderstorms, but it can also be created without the much of the rainfall or without much of the thunderstorms. They can also be created. These are the different phenomena that is associated with different air movements, which is mostly related to air pressure. That means high pressure to low pressure. Now the floor is open. Any, if you wanted to ask me any question regarding today's lecture, you can ask me. So if you have any question regarding cyclones, tornadoes, or thunderstorms or lightning, you can please ask me.
No, sir.
Okay. uh, in this lecture, I have included the different videos in here, so that you can get information from here, and it is open. You can just go to follow the links in YouTube, and you can get the information from there, and you can understand it well. If you cannot understand, just ask me again, so that it can be more clear. In your exam, the question could be like, how a cyclone can be formed, or how the lightning, what are the different conditions that need to form a cyclone or a tornadoes, or maybe what are the mechanism that involved in a lightning. So this type of question may be very important for you, or it could become like some short notes about cyclones or tornadoes or thunderstorms. So this way, you should take preparation depending on the information, and I'm gonna upload the other sources that I provided at the downside of each slides. So if you don't have any other question, then I should stop here, and maybe we're gonna come to the next Monday. Is it okay, Siam? Next Monday?
सर CMS सर चार्ज से इशू किसी फोन है सर, फोन और ऑफ हुई किसी सर.
Okay, no
जी सर.
problem. No problem. So, can you just take some screenshots of your total attendees, and then you can give me the absent roll numbers, because I'm now seeing 18. Maybe one or two already been disconnected. So you can give me the absent roll number later. Is it possible for you?
Yes sir, CM will provide you the sir. Yes sir. Yes sir.
Okay. So thank you all joining me, and hopefully we're gonna come back in the next week. Thank you all.
Assalamu alaikum sir.
Walaikum assalam.